Hi, I'm Nigel Chivers and I'm really concerned about the environment. So much so, I've already made a few videos and I hope you watch them. I've talked about how the carbon cycle is great, but we got all this fossil fuel being burned so that it gets into the carbon cycle, and the CO2 in the world is going up. So CO2 in the atmosphere going up means the greenhouse effect is being increased, because the more CO2 happens, the more the temperature of the world rises. And when the temperatures of the world rise, we get rising oceans, and over time, that's going to demolish all of our coastal cities, and we're in trouble. So, what I thought I'd do today is just talk a little bit about what we call NET. It's a negative emission technology. It's a fancy way of saying that people are working on these technologies for taking CO2 out of the atmosphere. So what I wanted to do was just give you a taste of what's out there, and just talk about some technologies so that you have an idea of all of the different technologies being worked on, and maybe an idea of whether these are going to be feasible, because I think it's going to come down to you and me really being lower carbon emissions. We've got to lower our carbon footprint, as I've talked about in our other videos. This is going to be a great thing about negative emission technology, and I think it's going to be something that's necessary to help get the CO2 down in the world. But I think the biggest contribution is you and me lowering our carbon footprints and changing our habits. So with that in mind, let's just leap into it. IPCC is an intergovernment panel on climate control. They're the ones that are driving this technology thing. They're really guiding us, saying that they've got a goal of 100 to 1,000 gigatons of carbon that they want to take out of the atmosphere. And a gigaton, just for your info, is like 1,000,000,000 tons. It's huge. So if they want to take out a 1,000 gigatons out of the atmosphere by the end of this century, we really got to do a huge amount of research, and putting this research into scaling up huge types of plants and stuff. Just for interest, 35 gigatons per year is produced just by the power plants alone in the world. So not talking about all the industrial processes, all the drilling for oil, just power plants alone are making 35 gigatons per year. So really 1,000 gigatons per the next 80 years is not really a huge goal, but I think it's really a huge goal when you look to see how they're doing it. Number one on the technologies is getting reforestation. So we've had a lot of reforestation. I'm sure you've heard of the Amazon being burned down like crazy, and we got to reforest all of that area, because unless we reforest, that's a huge reservoir of carbon. So you and I can actually participate in this type of technology, because just planting a few trees can make a huge difference. They estimate that the cost per ton of carbon taken out of the atmosphere is about $50 per ton. So very expensive way of doing it, but it's one of the cheapest technologies we have right now. Farmland soil is another way. If we can increase the carbon in the farmland soil, it's about $100 per ton, so it's more expensive, but apparently it's an easy thing to do, because right now a lot of the soil out there is being exhausted of carbon. We're not allowing crops to rotate. We're having the soil become poorer and poorer as all the nutrients are taken out, and we're not replenishing those nutrients. So if we can do things to the soil to put the carbon back into the soil, that's a reservoir of carbon which we can actually increase. There's another thing called direct air capture, which is exactly what it sounds like. We've got technologies out there, and Bill Gates is funding this type of technology. It's huge. We're trying to actually, with energy, recapture the carbon in the atmosphere directly, and we're putting it into different types of minerals and stuff to recapture what's out there into something solid so we can store it. There's an existing technology in pulp and paper. There's existing technology in the petroleum industry, and Bill Gates is trying to utilize something that's existing because it's very easy to scale up. We don't have to make anything new in this technology. It's already existing, but we can actually make factories of this right now, and Bill Gates is putting huge numbers of dollars into a company that's being able to do this. Seawater recapture. Seawater capture is more viable actually than air capture because, as it turns out, there's much higher concentration in seawater than there is in air. So if we can capture the seawater CO2, we'll be a little bit further ahead because it's cheaper to recapture that type of CO2 than capture the CO2 in air. Mineralization. There's another technology where they actually take the different types of rock, and they have to be special types of rock. They pulverize it, which is actually very energy intensive, and they spread it on land, and it captures the CO2 from the air, and it reacts with the CO2 and it becomes solid. So as soon as it becomes solid, then what happens is that carbonization is ends up in the oceans and the rivers and stuff, and actually increases the acidity of all that. So it's not a great technology because it actually has a whole lot of problems associated with it. Another technology is called coastal blue carbon, which is a fancy way of saying they're looking at tidal marshes and they're trying to get back the wetlands which have been destroyed. It turns out that there's a lot of CO2 captured in wetlands, and they've been destroyed by us. So if we can get those CO2 back into marshlands by making the CO2 restoration, and by recapturing, it's good for the ecosystem, good for the environment, and it's good for recapturing all that CO2. Algae and sea plants and everything capture the CO2. They die, they become sediment, and they're actually recaptured for a long time because it doesn't go back into the atmosphere. We got things like algae and microbiology, very small technologies at the moment. Algae is a case of getting gene splicing. They get the algae so that they become very efficient at capturing the CO2 through photosynthesis. But again, bad things happen when CO2 is photosynthesized, is that it takes up oxygen too. So you have these algae blooms in the ocean, and they capture lots of CO2, but at the same time they destroy all the sea life in the ocean, because when oxygen is depleted because you have an algae bloom, it uses up all the oxygen and it destroys huge tracts of the ocean. So they're looking at it, they're trying to experiment with it and see what they can do with it. Microbiology is a way of fermenting things like E. coli, and E. coli can be made to, through gene splicing and manipulation, they can be made to recapture CO2 directly from the air, and it becomes things like formic acid and other byproducts which can be used in animal feed. It can be used in places like food preservation. It can be used in industrial use. So formic acid has all sorts of uses, and so do some of the other byproducts. But again, these are not a comprehensive list. It's not everything, but it gives you an idea that these things are still in the infancy and being worked on. But if everything is continuing to be worked on and scaled up, maybe we will meet the goal of 1,000 gigatons by the end of the century. But again, will it be enough to actually save us? Who knows? But let's not leave it to chance. Let's you and me work on the carbon reduction and lowering our carbon footprint. So hopefully I've given you some more information to think about, and Thank you for listening. I'm Nigel Chivers, and you have a great day. Thank you.